My name is Liam Robleski. Once more, I am here on behalf of the Schulich Ignite group. This is session 6 of the fall 2020 set of sessions. So I don't believe we have any announcements for the moment. So without any further ado, we will get started. And as always, if I have any issues, please do let me know in the Zoom chat so that I can see that and fix it as soon as possible. Okay, so as I mentioned, this is session 6, and we are going to get started with a brief overview of what we're going to be talking about today. So the first thing we're talking about is a way for us to check for mouse clicks. So up to now we've been able to check if the mouse is pressed, but this will let us run something only when the mouse is clicked. And then we're also going to talk about functions, and that's a pretty big topic, and that's where we're going to spend the bulk of our time today. So we're going to continue on with mouse input. Last time we talked about some things. Today we are going to be talking about mouse down. So what do we do if we want something to run only once when we click on the mouse? We can use mouse down for that. That says when any key on the keyboard is pressed. That should be when either mouse button is pressed. So when either mouse button goes from not clicked to clicked. And we can use mouse down the same way that we use setup and draw. So you'll see that this sort of template here looks very similar to the template that we have for setup and draw. And in here, let's switch over to the coding window, and I will show you how this works. So as always, I have the brief bit of boilerplate up there, so we run that to make sure everything's working. And we start with def setup, size 500, 500. We will do a background, that's going to be a lightish green, I think. 100, 120, 200, oh I'm sorry, that was 212, my mistake. And then we will say fill style white. And in draw, we don't actually have anything we particularly want to draw at the moment, so we're just gonna not really do anything. We're gonna say, I don't know, a equals 10. It's just something to do in there. And you can do whatever you want. I've just put a equals 10 as kind of something to have there. It doesn't mean anything. But then we can say def mouse down, and we can say circle at mouse X, mouse Y, and 50. So whenever we click the mouse, that should run. Is my text legible also? Let me know if there are any issues with that. That's fun. Something's gone wrong there. I forgot Ignite, thank you. %% Ignite right up at the top. Thank you for pointing that out. So when I run that, you can see that we get a circle drawn at each point where I click my mouse. And so that only happens when I click my mouse. Actually, let's switch back to that, and I will rerun it just to show you that if I click and then move my mouse around, I haven't released it, but you see the circle isn't following my mouse. And that's different from how things behaved when we were using mouses pressed, because if you had something like in draw, if we do something like if mouse is pressed, circle at mouse X, mouse Y, and say 10. If we run that, then I click my mouse, and now we see a circle that sort of follows my mouse. But the mouse down only runs the one time when I press the mouse down. Okay. So that's pretty much all we have on that. That's the last bit of sort of stuff we wanted to talk about as far as inputs go. So now we're going to be talking about functions. So functions are blocks of code with a name that we can call to perform some task for us, and it lets us run a bunch of code from one line. We've actually been using functions all along, but we haven't called them that because we didn't want to kind of introduce too much new terminology right off the bat. So the idea of functions is that we want to package a bunch of code all together so that we can reuse that bit of code whenever we want. It also makes our code much shorter, right? Because we're packaging all the code together, we don't need to rewrite the code every time we want to do that same thing. We can just call a function. An analogy for functions is something like a vending machine where there's various different things that it does, but it takes in money and counts it, and then it takes in the person's choice of food, and then it dispenses whatever item they chose if they had enough money. You could define all of those as functions, so that way you would define the way that the vending machine works as take money, take choice, dispense. Right? That would be how you would write it, but each of those is a lot of complicated steps, so you can package all of those together into kind of conceptually simpler blocks. And like I mentioned, we've been using functions all along. We've been using them like commands. So the print command prints something. The circle command or function draws a circle at the coordinates and with the size that we give it. Fill style sets the fill color, again, according to the numbers we give it or the string that we give it. And background sets the background color. And so all of those are predefined functions that we've given you, and they all do just kind of one thing. And that's kind of how we like to think about functions, is they're just a block of code with a name that does a thing. Sometimes that thing is giving us back a value. So some other functions that we've used are stuff like len. So len returns the length of whatever list you give it, and then you can store that in a variable. In this case, we've stored it in the variable list length. A different function that we've talked about is the keys held function. And so we can see keys held G. That checks to see if the key that you pass to it is pressed, and passes back the Boolean corresponding to whether or not it's pressed. And you can again store that in a variable. So another interesting thing we can do is make our own functions. So when we do this, we use this kind of template that you can see here. And these functions can do whatever we want them to. There's no kind of constraints on what these functions are allowed to do. The body of the function, which is indicated there with the comment function body, is whatever code we want to run over and over again, right? So functions are kind of, when you first start learning things, it can seem a little bit strange to use functions because they don't really seem all that useful, because you can just write the code a few different times and that works just fine. But you can see here on the right side of the screen, you might even be able to read it. There's some code that draws a bunch of houses. So over on the left we have the picture that's being drawn. You can see there's a lot of repetition in this code, and it would be really difficult to tell if one of those values was wrong. So when we use functions, we can do it like this instead. So now that you can see the code is much shorter, but it's also conceptually simpler, because if I switch back to this one, it's not actually all that clear what each of these kind of repeated code blocks is doing. Right? We know it makes a house, and if we run it, we can see that it makes a house, but just reading it, it's not clear what it's supposed to do. But if we define the function draw a house and use that, then that can do a lot more for us. It can shorten our code, it makes it a lot easier to change things, and a lot easier to see when things are sometimes incorrect. And it also lets us kind of wrap it all with this name that tells us when we read it back later, what exactly were we trying to do here. And you can see what we were trying to do is draw a house. So quick question number 1. Which of the following is false based on what I've said so far? And we will again have the Zoom poll popping up. And as usual, there will be about a minute and a half for that. So you're answering which one is false. So you have about 30 seconds left. Make sure you get your answer in. Five seconds left. Okay, and most people answered functions can only be called in draw. That is correct. So that is false. You can call functions wherever you can do any other code, right? You can do it in setup. If you don't have either setup or draw, then you can do it outside of both in the same way that we've done that before. We generally recommend doing it in setup or draw. Just it makes it a lot cleaner to know when things are running. So we're going to now go over the anatomy of a function. So we're going to create our first function. So you can see there's a little checklist over on the right side of the screen there. Oh, my apologies. I forgot to silence my phone. 1 second, everyone. There we go. Sorry about that. So, the anatomy of a function. Every function needs a name, every function needs a body, and then some functions can have parameters and a return value if you want. You will notice that right up at the front, and I didn't mention it in the checklist, is def. So def tells the computer that what we're trying to do is write a new function here, rather than just using some code to do something. In the same way that if tells the computer that we're trying to do an if statement. So, function names. So, names are pretty straightforward. All functions have one, and it's what we use to call our function. And in case it isn't clear, calling is the word that we use when we say that we want to run the body of a particular function. So, it's highlighted in the box in red there, and you can see over on the right a simple function that won't actually work. But we can see that its name is greeting. Right? And it won't work because it doesn't have a body. Comments don't count. So this function wouldn't work. So we're going to talk about the function body. And this is where we say what the function does. So when you're writing code that goes in a function, this is where you will write it. And so now over on the right, the function greeting that previously wouldn't work now has print hello in it. And so when we add print hello to the body of the function, that code will run when we call greeting. So we have a simple example of a function. It's a function that just does something. It just does one task exactly like we want. It doesn't accept any parameters, which we'll talk about. It doesn't have a return value. The name of the function is greeting, and the body of the function is one line. Print hello, everyone. And one other thing that I didn't mention that is also important to have is the parentheses and the colon there. So when we want to add our function, it is also important where we do that. So we need to create our functions outside of setup and draw. And so that means that we need to make sure that we go back to all the way to the left when we define it, the same way as we did for mouse down, right? And in fact, mouse down is a function. So then calling our function will look very, very straightforward. So once we've created it, we can call it anywhere that we can run any other code. So here we've called it in setup. We could have called it in draw, but that would do a lot of printing. So we're just going to call it in setup for the moment. I'll switch us back over to the coding window. Yeah, there we go. We will do a new one here. So we'll say def setup, say size 500, 500. I'm just going to set us up with our very basic sort of boilerplate. So def draw, parentheses colon. And we say background 175, 175, 255. That should be a light blue, I think. And now that we have our template, let's go define our new function. So we'll say def greeting with 2 parentheses, colon, print, hello everyone. And in setup, we will call that function. And we'll say, oops, greeting, and parentheses to indicate that we're calling the function. So when we run that without accidentally running the code above it, we can see it prints hello everyone right below the canvas. Exactly like we would see with print hello everyone, but we've now given it a different name, right? And we could come in here and change this string here, and it would work everywhere we called greeting. So if we wanted to do greeting 3 times, that would be very simple, right? So if we wanted to print hello everyone 3 times, that's starting to get really annoying with it scrolling back up. It prints hello everyone 3 times. But if we wanted to change that to say, instead of hello everyone, we don't like that phrasing, we could say hello everybody. We change that only in one spot, and now it changes here. Kind of like how variables let us write the same code, but with changing values. Functions do much the same thing, but they let us also write the code fewer times. And so with that, we've come to our first exercise for the evening. So here we're going to create a random circle function. So we would like that function to be called when the mouse is pressed. So that should be using mouse down. The function should draw a circle at the mouse position with a random diameter and a random color. And don't forget about the randint function. That will give you a random integer from 0 to 50. So Emil, if you can send us to breakout rooms when you are ready. Okay, looks like we've got just about everybody back. So I will briefly go over the way I would solve this, and then we will continue onwards. Whoops. There we go. So we will add a new cell, and in here we will put in our usual stuff. So def setup, size 500, 500. Then we'll say def draw. And here we again don't really want to do anything in draw. We want to do it all whenever we press the mouse. So we'll say a equals 10. Again, just as a nothing statement. We will say def mouse down. And we will say that we want our radius r to be 25 plus a random number, random integer from 0 to 50. So by adding 25 to that, we get a random number from 25 to 75. And then we will say our color red is going to be a random number from 0 to 255. So is our green color, and so is our blue color. Oh, I'm sorry, this asked for a diameter from 25 to 75, so we'll just make that D instead. Then we will do fill style, color red, color green, color blue, and we will draw a circle at mouse X, mouse Y, and with diameter D. Let me run that. What have I done? I did miss background, but that shouldn't really do anything. We'll put it in anyway. I'm not quite sure what's going on with that. Try fill circle. Okay, we'll try fill circle. Somebody in the chat reported that fill circle seems buggy. Oh, and rand int as well. Thank you for pointing that out. There we go. So you can see we get circles of all sorts of different sizes and with randomly varying colors. Sorry that took so long. I did not expect to make that many mistakes in a simple function, but happens to everybody. So we will continue onwards and talk about function parameters. So most of the functions that we've been using without knowing they were functions accept inputs, and those are the parameters. So the parameters are, when you write code inside a function, parameters are like special variables, and those are set by whatever you call them, whatever you call the function with. So inside the function body, it treats them like normal variables, but the value gets passed in when you call the function. So here's an example of a very simple function, and it takes in two parameters, a and b, and it prints the sum of the two inputs. So sum equals a plus b. Right? So when we call this function, we can call it with numbers. And in fact, I will just quickly switch us over to here. So we will do, I'm going to say def add a b. You'll say sum equals a. When something's highlighted in green, that generally means it's a special thing. And you generally don't want to overwrite things that are special words for the language, so I'm just going to call it sum underscore, just to add some nonsense that is still understandable. But we'll say sum underscore is a plus b, then we will print sum underscore. And down here, I will call add 3, 2. If I run that, you can see it prints 5, and that's exactly what we would expect. But I could also call it with some variables. So if I make two variables, let's say a equals 3 and c equals 2, and I call it with c here and a here. Oh, thank you. I'm on the wrong screen. There we go. So this is the code we have, %ignite. Then we are adding a and b. Sum underscore is a plus b, and the green text I was mentioning is just when we don't have an underscore on the end of it, sum turns green, kind of like print. That just means that it's a special word. Okay, and then if I call it like this, where we have a is 3 and c is 2, call it like that, it still passes those values in. And you can see that even though we've used a here and a here, it doesn't matter, because this a is within the scope of add, if you remember our discussion about scope. In order for it to refer to this a, we would have needed global a, and we didn't do that. So this a is its own thing, and it refers to the parameter a. So that's a simple function that takes parameters, and you can see that it works with variables, it works with numbers, all of that just kind of works very straightforwardly. And you can see again here, we go through it, we say inside the body of add, it treats a as being the value 3 and b as being the value 5. So here it would print 8. So here we have quick question number 2. So we have fill in the blanks. We're defining a function divide by 3. And we have the first blank inside the parentheses. And then later on we are calling we're calling our function presumably. So what do we want to see in those blanks? Again, answering on the Zoom poll, and the total time of about 1.5 minutes, of which you have used about 30 seconds. And you have about 30 seconds remaining. Now about 10 seconds, so make sure to get your answers in. And that is time. So as you can see, most of you answered blank 1 should be number, and blank 2 should be divide by 3. And that's correct. So when we look at this, we know that we want our result to be number divided by 3. And so when we call divide by 3 with some number, in this case we'll want to call it with 10.32, but with some number, that number should have the name number. And so we give our we name our parameter. Inside the parentheses, we name it number. And then later on, when we want to call our function and divide 10.32 by 3 and print the result, we need to use the name that we gave to the function, and that name was divide by 3. So the other thing that you can put in that isn't technically necessary for functions is a return value. So this is what a function gives back to us, in the same way that len of a list gives us the length of the list, and various other functions give us various other things to work with. These return values give us something back that we can work with. It can be anything, it can be a number, it can be a string. All of those work very nicely, and you can then store them and use it for later. So a simple example of a function that just has a return value is the function 2 plus 2 on this slide. So it just returns an integer, and it doesn't take in any parameters. So here, when we define 2 plus 2, we set the variable answer in the function body to be the result of 2 plus 2, and then return the answer. And I hope you all can figure out that that is 4. So then we set x equal to 2 plus 2. So when we call 2 plus 2, it returns 4 to us, and we store that in x. Then we print x plus 1, and 4 plus 1 is 5, so that will print 5. Another slightly more complicated and also useful example is this one here. So we have a function calculate cube volume, and so that takes in the parameter side length, and it returns side length times side length times side length. And so that'll be the volume of a cube with side length. And in this case, that will print 8. It is important to note return and print are not the same thing. Return lets us use those values later. Print does not. Print just shows it, and then it's done. So we will quickly just show this, and then we will go to our second exercise for today. Now I'll switch us over to coding. $ignite def setup volume equals calculate cube volume at 2, and then we will print a cube with side length 2 has volume, and then we will print whatever our function returned to us. And then down here, we need to define our function. So you'll say def calculate cube volume with the parameter side length, and that will be return side length times side length times side length. And so when we run this, we can see that it doesn't draw anything, but it does print out for us a cube with side length 2 has volume 8. So with that, we will go to our second exercise for the evening. So here, we would like you to create a function called average, and that should accept 2 inputs. And it's worth mentioning that when you want to use multiple inputs, you just separate them with a comma. And then when the mouse is pressed, you want to call average, pass in mouse X and mouse Y as parameters, and draw a circle at the position of the mouse with the return value of average as its diameter. So Enmol, once again, to breakout rooms when you are ready. Okay, looks like we have just about everybody back. So I will briefly go over how I would approach this problem, and then we will talk about some other stuff. So we'll switch this over to the coding window, and we will scroll to the bottom so I can do, oh goodness. There we go. Okay, so we'll start off with our standard boilerplate, $ignite. Def setup, size 500, 500. And in here we will also draw our background. We will do that in a, say a light blue. Oops. And we'll do, say, 150, 150, 200. And then in draw, this time what we want to do is say if the mouse is pressed, then we want to set our diameter to be equal to the average of mouse X and mouse Y. And we want to do the outline of a circle, so stroke circle. Our position will be mouse X, mouse Y, and our diameter is D. And that's pretty much all we need there, but we still need to define our function average. So let's go do that. I'm going to say def average. This will take in two numbers. Let's call them A and B. Close our parameter list, colon to say we're done. And then in here, it's pretty straightforward. We just want to return A plus B divided by 2. And that should be our average. And so when we run this, you can see that's pretty purple for a light blue, but okay. You can see that as I move my mouse around, if I move it either down or to the right, it gets bigger, and when I move it down, when I move it both down and to the right, it gets very large. And again, this only happens while I'm holding down the mouse button. And that's pretty much what we expected from that exercise. So the last thing that we want to talk about for functions is using global. I mentioned this earlier. Just like when we use draw and we use setup, if we want to use other functions from, or other variables from outside of our functions inside the functions, we need to use global to let the computer know that it should look outside of our function for that variable. So the example here is we have a shopping list at the global level, and then in setup we call print list. And then print list, we want to go over our shopping list and print each item. So we start by saying global shopping list, and that tells print list to go look at the global level for the variable shopping list. We say for each item in the shopping list, we want to print that item. That'll go through and it'll print apples, oranges, basketballs. Fun shopping list. Sounds like a good time. And with that, that's all the actual content we have kind of at the basic level of programming. So we've gone over most of the basic logical structures that you will need to make pretty much any program that you want. So what's next? What's next is you guys are going to have some time to work on projects. So these are totally optional. You can earn up to 250 Ignite points for one project. And the deadline for these projects is December 22nd, 11:59 p.m. So they will be marked on 5 categories: readability, efficiency, novelty, functionality, and complexity. So it doesn't matter if your project, whatever it is not super complex. You can still get a decent number of points from it based on how things play out and how kind of, is it readable, is it efficient, all of that. So the overall rubric and the description of each category can be found in the Ignite Points spreadsheet. I'm going to ask that somebody post all of these links in chat, please. You can submit as many projects as you would like before the deadline. Submitting your project will be via the same process as weekly and the weekly and social media challenges. So the forms are there, and again, I'll ask that those links be posted somewhere. They will be available. You don't need to worry about copying these down or screen grabbing or anything. And then the other thing we want to talk about is our gala event, and that will be on December 10th and that will run from 6 p.m. to 8 p.m. So we would like, we run this every year at the end of the sessions to celebrate your completion of Schulich Ignite. So we'll have some industry speakers there for you guys to interact with. You can showcase your projects to industry speakers, mentors, everyone else who's participating. And we would really, really appreciate if you guys would show up. So we would like you also to fill out the survey at the link there. Again, that will be posted. And if you want to present a project during the gala event, make sure to have that ready for presentation by the day of the gala event. If you need help with your projects, we will be running sessions next week and the following week where you will have opportunities to ask us kind of directly. But you can also please join us on Discord, ask any questions that you have there, and show off your work so far. If you finished a project and you would like it to get a shout out, please let your mentor know, and we would be happy to do that for you. I had a thing I wanted to add to this, but I've now forgotten what it was. So I will continue on to our exercises for this week. Oh no, I have remembered. At least next week we will be talking about some more specific things for the purpose of games that we will be letting you guys work with. So that's kind of less programming in general and more the specific tools that we're working with. But those may be helpful for your projects, so please do come to that as well. Okay, and now with that out of the way, let's talk about this week's exercises. So the Bug Busters exercises here, we have abject horror on the left, so we would like it so that when you click your mouse, a horrified face shows up where you clicked. And over on the right, we have mini dartboards. I imagine we would like these to be done using functions, please, for full marks. But it's not listed here, but I believe that's the intended kind of solution path. And then the Pythonic lava exercises, we have the one on the left, that is press and C, so that is, it should keep track of how long you hold the mouse for and draw that many circles. And ideally you would have the counter up in the top right corner, but that is not needed for full marks. And on the right, we have your rect is 2 clicks away. And so there we would like it to be so that you click at 2 points and you draw a rectangle between those 2 points. And the orange dot that you can see on here is also not needed for full marks, just the clicks to draw the rectangle. And here we have some inspiration for projects. Over on the left we have Flappy Square, which is starting to be an outdated reference now, and I'm sure that makes all of our mentors feel horrendously old. And then over on the right we have a sort of, I'm not quite sure what you would call this, but a simple game where you fight against swarms of shapes. And the code for both of those is available on our Google Drive, and I'm sure the link for that will be posted as well, anywhere that you would like to see it. And so with that, I think we reached the end of the stuff I need to talk about this evening. So we will go back to our breakout rooms one more time for you guys to have some time to talk to your mentors, work on these exercises, ask any questions that you have about the gala. Again, please do sign up. We would really appreciate it. So yeah, to our breakout rooms when you are ready. And well.
me safe and free from harm. These days, everything's changed. Pull me through my darkest days, a constant phase where everything's a game. Always stuck another day. And I know you needed me to come back home, but I'm not gone, and you gotta find a way to move on, cause the times are changing, the past is rearranging itself to fit the way that you feel. And you know I'll always find my way back home to you, home to you. Days, a constant phase where everything's a game. Always stuck another day. Found ways to break away. In time, I know you'll do the same. The end is near, it'll be crystal clear. And I know you needed me to come back home, that I'm not gone, and you gotta find a way to move on,
Okay, that looks like we've got just about everybody back, I think, at this point. I think so. So, for those of you who stuck around to the end, thanks again for joining us this evening. I hope you all had a good time. I hope you learned something. And please do go sign up for the gala, and I will see you next week. Cheers, all.